Good morning, students. Today we are dealing with the part 7 areas related to circles. From each corner of a square of side 4 centimeter. Square of side 4 centimeter. AB, BC, CD and DA of 4 centimeter. A quadrant of circle of radius 1 centimeter. This is a quadrant. You can see on 4 sides we have quadrant. Quadrant is a part of the circle. It is 1/4 of a circle having radius 1 centimeter. Is cut out and also a circle of diameter 2 centimeter. Circle of diameter 2 centimeter is cut as shown in figure. Find the area of remaining portion of the square. So how to find out area of the remaining portion? That means the shaded area here we have to find out. This is a part of the square. Complete portion is square, from which we have to subtract all these 4 quadrants as well as the circle having diameter 2 centimeter. So first we have to find out what is area of the square. Then we have to find out area of the unshaded portion. Then by subtracting area of this unshaded portion, that is 4 quadrant area plus area of the circle inside, that must be subtracted from total area of square ABCD. Let us find out each part. First we will find out what is area of the square, for which we have side of square is given. Let us write side of square. How much it is? Side of square is equal to 4 centimeter. Therefore, area of the square. Area of square is equal to side square. Side square, that is equal to 4 square. We can say 4 square is 16 cm square. One value we got. Now we have to find out area of 4 quadrant and as well as area of the circle. What is the diameter of the quadrant here? Radius of the quadrant, that is 1 centimeter. What is the diameter of the circle here? It is 2 centimeter. If diameter is 2 centimeter, half of it, that radius will be 1 centimeter. Okay, so radius will be 1 centimeter. That is area of unshaded portion. We can write area of unshaded portion. Area of unshaded portion equal to area of 4 quadrants plus, we have to write it as area of 4 quadrants. Quadrants plus area of the circle. Area of circle. So here in all the 4 cases, that is in all radius of these 4 quadrant, it is the same, and also radius of the circle is same. So what is area of the quadrant formula? It is 1/4 of pi r square. Pi r square is area of the circle. Here quadrant is only 1/4 of it, but we have 4 quadrants. So 4 into 1/4 of area of circle, that is quadrant area, plus area of the circle we have to find out, that is pi r square. Radius is same in all these cases. Okay, so let us simplify this. We will be getting pi r square plus pi r square. Now how much is pi r square plus pi r square? Isn't it? This is 1 pi r square plus 1 pi r square. It become 2 pi r square. So pi value here we have to substitute 2 into 22/7 into 1 into 1 centimeter. Okay. So this comes as 44/7. 44/7 cm square. So let it be there, or we can divide it and find out. There is no problem. Let us divide and find out. 44 divided by 7. How many times? 6 7s are 42. 2 comes as the remainder. Give 0. How many times? 7 2s 14. 6 60. So here 8 times 7 8s are 56. It goes on. So here we can have the value 6.28 cm square. This is also one of the important value. Here we got area of the square and now we got area of all this unshaded portion. Therefore, let us come back to the question. Find area of the remaining portion of the square. That is area of remaining portion. The meaning of remaining portion here, it is actually the shaded portion. Remaining portion. Area of remaining portion equal to area of the square. Area of the square minus of area of 4 quadrants plus area of circle. So area of 4 quadrants plus area of circle. Okay, so here we have the value. Area of square we have found out, that's equal to 4416 cm square minus of these two things together we have found out, area of 4 quadrants and area of the circle. Here we have seen, so 44 by 7 we found out it as 6.28. So let us be in the bracket so many cm square. Now we have to subtract this, that is 16 minus 6.28. So subtract and get the answer 6.28. 8 plus 2 10, 3 7. Okay, so here we have 15 minus 6, it is 9. So the answer is equal to 9.72 cm square. That is the area of shaded region or remaining portion. Second question, in a circular table cover of radius 32 cm, OA, OB, OC. They are the radii of the circle, radius 32 cm. A design is formed leaving an equilateral triangle ABC in the middle are shown in figure. So triangle ABC is an equilateral triangle. Find the area of the design. This is the question. So what is the design actually? Isn't it segment? So here we have a segment, here also same type, here also same type. So 3 segments are there, 3 minor segments are there. So how to get a segment? Same figure here I have drawn showing only one segment. So how do we get this segment? Here OA and OC I have joined, and here OAC is a triangle and OAPC, here if I mark a point P, OAPC is a sector or sector AOC we can say. Here we have a sector. From sector we have to subtract the triangle to get segment. That already we have learned in the previous classes. How to get a segment? That is area of the sector minus area of the triangle. So what is area of the sector formula? Theta by 360 into pi r square. So how much is theta we have to know. That means here also if I join, you will be getting 1, 2, 3 angles. So 3 angles sum is equal to 360. Therefore, what is each angle? This angle equal to, what is angle theta is equal to? Total is 360. That should be divided by 3. So how much will it be? It will be 120 degree. Now central angle we got as 120 degree. So angle AOC is 120. So sector we can find out theta is 120. Theta by 360 into pi r square. That is sector. From which we have to subtract triangle area. For triangle only we know what is the radius, 32, and here OA is also 32. But what is the use? We cannot find out with the radius. Okay, so here I have drawn a perpendicular from the center to the chord. So my construction is, we have to draw OM perpendicular to AC. So it's a perpendicular drawn from center to a chord. Therefore, it bisects the chord. Therefore, AM will be equal to CM. These two portions, AM will be equal to CM. Okay, so if both are equal, so it divides the angle also equally. So here I can say that if this is 120, this angle will be 60. This is 90 and this will be 30. Okay. So two equal angles are made here, two congruent angles are made because a perpendicular drawn from the center to chord bisects the chord. Here you can see a right angle is formed in both the cases. This AM equal to MC is there. That is right angle is there, and here we have these two things, sides equal, and this is common also, side angle side. Side angle side, by which these two triangles are congruent. Therefore, directly we can write angle AOM is equal to 60 degree. So 120 is divided equally. So 60 we are getting angle AOM. So no need of writing about the congruence, just try to understand. So it will be very lengthy if you write everything. Okay, so here we have angle AOM equal to 60 degree. So what is the purpose of drawing this OM perpendicular to AC? For this triangle AOC, we can have O as the vertex from which to the base of the triangle I am dropping a perpendicular. That means OM is the height and AC is the base. So area of the triangle will be half BH, half into base AC into height OM. That is my idea. So for finding out AC and OM, we have to use some trigonometric ratios which you have seen already. So we are consider right triangle AOM or OMA in whatever may be the form, no problem. We are considering right triangle OMA. So what is sine 60? 60 degree here we have. It's an acute angle. So sine 60. Sine 60 is opposite side by hypotenuse. Okay. AM by OA. So AM value we do not know. Let it be there. Whereas OA we know. OA is same as OC, that's equal to 32. What is the value of sine 60? Isn't it root 3 by 2? So here we have found out root 3 by 2 is equal to AM by 32. So we need AM. AM is half of AC because perpendicular drawn from the center to chord bisects the chord. So keep AM as it is. Transfer 32 to this side to the other side, become 32 into 32. So AM you kept as it is. Therefore, it is 1632. AM is equal to 16 into root 3. Okay. 16 root 3 unit you can write. It is AM means only the length. It is 16 root 3 centimeter. It is AM is the length. Okay. So what will be AC then? Is it AC double 2 times AM? That's what I said. AM and MC are equal. So the reason is, here you can write the reason. Perpendicular drawn from center to a chord. Center to a chord bisects the chord. So that is the reason here you have to mention. So AC equal to, AC is actually the base of the triangle. That's equal to 2 times AM. AM is 16 root 3. 2 into 16, 32 root 3. Okay. Root 3 value everybody knows. We can find out what is 32 root 3 also. There is no problem. So 32 into root 3 value 1.73. Let it be there. We can find out later. Now here we got AC Now what do we find out? We have to find out the perpendicular. How to get the perpendicular? So which trigonometric ratio is better here? Shall we have cos 60 degree? Cos 60 is adjacent side by hypotenuse. For 60, AM is opposite, OM is adjacent, and OA longest side, that is the hypotenuse just opposite to right angle. So cos 60 is adjacent side OM by hypotenuse OA. So what is cos 60 value? Isn't it 1 by 2? 1 by 2. Okay. So OM by OM we do not know. By OA is 32. Therefore, what is OM is equal to? You have to transfer 32 to this side. So OM is equal to 32 by 2. 32 by 2 is 16. So OM is equal to 16 centimeter. So we got next value also. AC here we got AC is equal to 32 root 3. Base we got. Height OM also we got. OM is equal to 16 centimeter. Now let us find out area of the triangle. Therefore area of triangle AOC, that's equal to half into base AC into height OM. Just a substitution here now. We are going to substitute. Okay. So that's equal to half into AC is 32 root 3. AC equal to 32 root 3 and OM is equal to 16. Here you can simplify. What do we get? By 32 when you divide becomes 16. 16 into 16 is 256 and root 3 value 1.73. So 256 into 1.73 we have to find out, that is 256 into 1.73. Multiply quickly. 18, 15, 16, 7, 68 comes here. 6 sevens are 42, 4 remainders and 5s are 35 plus 4, 39, 3 comes. 7 2 is 14 plus 3, 17. 1792. Next comes 1 into 6, 1 into 5, 1 into 2. So add it now. Here we get 16 plus 6, 22. 9 plus 5, 14. Okay. So here we have 2 decimals. The answer here is 442.88 cm square. That is the area of triangle AOC. It's very important. So what is the next step? For finding out one design, that is area of the sector. Here you can see the figure. Area of the sector minus area of the triangle. So area of the sector formula. Therefore area of sector AOC, that's equal to theta by 360 into pi r square. So theta value we know there. Central angle is 120 degree. Okay. Central angle 120. Therefore this is equal to 120 divided by 360 into 22 by 7 into radius. Radius is 32 into 32. So how many times 120? 3 times. 120 1 time. Okay. So here we are not in a position to cancel anything. We must multiply. What is that we are getting? We have to multiply each value. So 32 into 32 into 22. Do the calculation. You will be getting it as 22,528 divided by 21. 3 sevens 21. Okay. So let us divide and get the answer. 22,528 divided by 21. 1 time. Here we are getting 21. left with 1, 15 here we are getting. In 15 it will not go, so give 0. Bring down the next one. So how many times? 7 times. 7 into 21. How much we get? 7 into 21, 147. Okay, subtract again. 5, 8. Okay, 58 we are getting. What is the next value? 2 times only 42. Subtract now. When we subtract, how much we get? 58 minus 42. Okay. 58 minus 42. 16 here we have. Yes. Now give the decimal, put the 0. So 21. How many times? So chance of getting 7 times. 7. 7 2 is 14. Subtract again. 3, 1, 0. So you may get 6 times. So it continues. So let us have the value 1072.76 cm square. That is area of the sector. Now area of sector we got, area of the triangle we got. So therefore area of one segment is area of sector minus area of the triangle. See area of segment, area of one segment, that is area of the sector minus area of the triangle. Area of sector we got 1072.76. Is it 1000? That's equal to, here we can write it as equal to 1072.76 minus area of the triangle we got. What is it equal to? Isn't it 442.88? 442.88. So many cm square area. So now we have to subtract 1072.76 minus 442.88. Subtract, what do we get? 8 plus 8, 16. 9, 9 plus 8 again 17. Comes 3, 3 plus 9, 12, 5 plus 2, 7, 10 minus 4 is 6. 629.88 here we are getting. This is equal to 629.88. This is only one segment. Therefore, area of what was the question? Come back to question, find the area of the design. Therefore, area of design equal to area of 3 segments. Area of 3 segments. That's equal to 3 into area of one segment is 629.88. Multiply. So, you will be getting the answer 1889.65 cm square when you multiply it by 3. Okay. This is one of the simplest problem. Question number 3. In figure ABCD is a square of side 14 cm. ABCD square of side 14. If it is 14, as they are touching each other, we can see it is made into 2 equal halves. AB is divided equally as 7 and 7. So radius of each circle will be 7. Everywhere it will be the same. This will be 7. 7 goes on like that. With centers A, B, C and D, 4 circles are drawn. Center A, B, C, D. So 4 circles are drawn with these centers such that each circle touch externally 2 of the remaining circle. So this circle with the center A is touching circle with the center B and also with the circle with the center D. Similarly, circle with the center D is touching circle with center C and also with the A, mutually in contact with the 2 circles. So find the area of the shaded region. Okay, find the area of the shaded region. So is the shaded region a part of the square? You don't want to think about other this unshaded portion. Just see what is ABCD here. It's a square from which what all things we have to remove. We have to remove these small quarters. They are unshaded portion. In order to get the shaded area, we have to remove the unshaded area from the square. No need of taking the complete one. Okay, here from the square is having many parts. 4 quarters are there and also the shaded portion. So we have to subtract these quarters from the square. Okay, therefore directly we can write area of shaded region. Here we can mention side AB equal to BC equal to CD equal to DA, that's equal to 14 centimeter. Therefore, radius equal to 7 centimeter. That will be better. Area of the shaded region equal to area of square minus 4 into 4 quadrant. 4 into area of quadrant. 4 into area of quadrant. So let us substitute the values and get the answer. That's equal to area of the square. Square is having side 14. So 14 square minus 4 into quadrant area 1 by 4 pi r square. Now substitution. What is 14 square? Isn't it 196 minus 4 getting cancelled? 22 by 7 into radius I have marked as 7. So 7 into 7. We can cancel 2 7s. So 196 minus 22 into 7. 154. So many cm square. Okay. We will subtract what is 196 minus 154. Subtract will be getting 42 cm square. That is the area of shaded region. Let us see the fourth question. It's simple, but you listen properly. Okay. Figure depicts a racing track. You can see the racing track here, whose left and right ends are semicircular. By dotted lines I have showed it. It's a semicircular area on right as well as left. Distance between two inner parallel line segment is 60 meter. So 60 meter is between inner parallel line. So this is 60 meter from here to here. Okay. So from here to inner parallel line, between that 60 meter. And they are each 106 meter long. So 106 meter is the length of the track. So not for the semicircular area, we are considering like this, and here comes this length, this point to this. Okay, so if we mark it as A, B, C and D. Here AB equal to 106 meter and CD also equal to 106 meter. That is the meaning. Length of the track. Okay. If the track is 10 meter wide, the width means this is the width. Okay, this is the width. It is 10. So everywhere it will be the same. Here also it is 10. So everywhere the width is 10. That is what I have shown in the second figure. I have taken only the semicircular portion. Only one semicircular portion. Here I will be showing the distance here. It is 60. This length is 60 meter. That is inner tracks difference. Inner tracks is at a distance of 60 meter. If this is 60, half of it will be 30. So this also will be 30. Whereas this width is 10. That is how we have to consider. Find distance around the track along its inner edge. So what's meant by distance along the track? In the inner edge, this one. Yes, this length. It is the perimeter we have to find out. This is the distance along the track of the inner edge. Okay, so this is what here we have to find out. Even if it is outer or inner, this length will be the same 106. Here also it will be the same 106 meter. Then what is this length we have to know? Isn't it circumference half? Circumference of the circle, it is a semicircle. So circumference of circle is 2 pi r. Therefore here this length is pi r. Radius we have seen it is 30 meter. Okay, so here also this length means this arc length is pi r. That is semi-circumference of circle. Okay, so that will be the first one to find out. Number 1, what is that? Here we have to write distance around the track along inner edge. Distance around the track along its inner edge. That is equal to, as I told you, length, then the semi-circumference, then again length, then the semi-circumference. So 106 plus 2 pi r's half is pi r plus 106 plus pi r. So as it is length, unit is meter. Now let us substitute radius as well as pi value. How much we will take as pi? 22 by 7 itself we will take. So let us see how to do. So 106 plus 106, it is 212 plus pi r is 2 times pi r. So 2 pi r. So 212 plus 2 into 22 by 7 into radius, inner radius is 30. So this value here we have to find out, that is 22 into 2 into 30. So we have to multiply, therefore 212 plus 22 into 2 is 44, 44 into 3, that is 132, so 1320 by 7. So we have to divide it, 1320, 1320 divided by 7. How many times? 1 time, 7 plus 6. Okay, 62, 8 time, 7 8s are 56. Subtract, bring down 60. Again 8 time, 56. Subtract, decimal 40. 7 5s, 35. Remainder 5, 0, 7, 7, 49, it goes on. Okay, so here we have 212 plus 1320 by 7 is 188.57. So we have to add both. What do we get? Isn't it 400.57 meter? 400.57 meter. That is the length of the track along the inner edge. Now area of the track here we have to find out. So how to get area of the track? First you see the figure. Now let us consider it as part 1. We will mark it as part 1. This is 1 I will consider. This is 2. This part is 3, that is semicircular area. This part is 4. Okay, 1, 2, 3, 4 areas. So how to find out this total? Area 1 plus area 2. Area 1 means this is the shape of a rectangle. Here you can see a rectangular portion. Length is here as 106. Breadth is the thickness of the track. Is that equal to 10? So length into breadth is area of the rectangle. So 2 times we have to do. That is how we are getting this long path. Then the circular area, it comes as a ring. Half of the ring, isn't it? How to get that? Is that, for that I have drawn this one. So how to get this area of the shaded region? How to get this? That is area of the bigger semicircle minus area of the smaller semicircle. What is area of semicircle? Half of pi r square. So that is how we have to find out. Okay. So let us find out that. First let us find out what is area of 1 and 2. That is area of 1 and 2 together we can do. Area of 1 and 2. That is 2 times length into breadth. That is 2 into length is 106 into breadth is 10. So let us multiply 106 into 10, 1060 into 2. So the total of it become 12, 1 remainder 2. Isn't it? 6 2 is 12. Yes. 1 into 2. Yes. So 2120, 2120 meter square is area of 1 and 2. Okay. Now area of 3 and 4 here you are finding out. For first one, or this is the fourth area. Similarly we have third area also. How to get this area? Area of outer semicircular portion minus area of inner semicircular portion. So into 2 here we have to give. Okay. Therefore area of area of 3 and 4, that's equal to, so what is the formula? Isn't it pi r square? So pi a half of pi r square actually, area of the semicircle. So how to do here? It is capital R square. Here we will write half of pi r square minus half of pi small r square. That is area of the half ring. That is shown in the figure, children. See once more. Semicircle's area half pi r square. So first of bigger circle, radius will be 30 plus 10. 40 will be the radius. So capital R will be 40. Capital R is equal to 40 meter. Small r is equal to 30 meter. Okay. How many semicircular portions are there? Don't you have 2 semicircular portion? Therefore, this is equal to 2 times. 2 here itself we can write 2 times half of pi r square minus half of pi r square. So half also you take out, half into pi also can be taken out, then left with the r square minus r square. Once more I will explain. Half pi r square, outer bigger semicircle minus inner semicircle smaller. Difference of that will be the shaded area. So 2 shaded areas we have, third and fourth. So 2 into half pi r square minus half pi r square. R we are getting as radius 30 plus 10 width. So 40 and here it is 30. We can cancel this to pi value 22 by 7. This is a square minus b square. A plus b into a minus b. That is a plus b. R square. R is 40. Small r is 30. A plus b into a minus b. A minus b. Okay. So here again we have to simplify. (22 by 7 into 70 into 10). How much we get? So 7 and 70 will be cancelled. We are getting 10 times 22 into 100 is 2200 meters square. Okay. So now area of the track. We are coming to the last point. Area of the track equal to almost all the part. Area of 1 plus 2 plus 3 plus 4. Okay. Area of 1 plus 2 plus 3 plus 4. Yes. That is 1 plus 2 we have got in the first equation. It is 2120 plus third and fourth together 2200, 2200. So take the total. So here we have 0, 2, 3, 4. Okay, 4320 area in meter square. Okay, hope you understood. Bye.